Hello everyone. Today we are learning image formation by convex lens. In this concept, we are going to draw ray diagrams and form images. So let's start with image formation by convex lens. So we are starting with the first ray diagram in which the object is at infinity. When the object is at infinity, that means the lines are parallel to the principal axis. Now, before starting with this, first we should know what is a principal axis, what is a principal focus. See, the first thing, this line, this is called the principal axis. Here, this is the principal focus. Since this is a biconvex lens, there will be two focal points, f1 and f2. Similarly, double the length, double the focal length is 2f1 and 2f2, which we call the center of curvature. So these are the important points. And there is also a very important point, which is the optical center. This O is called the optical center. Now, so when the rays are parallel to the principal axis, the rays are parallel to the principal axis, it passes through focus. So we are drawing two straight parallel lines through the principal axis, and they are meeting at focus. These are the two rays. After refraction through the lens, they meet at focus. So if you have to write down the properties, so first one is image is formed at focus, or we say F2. Second, images, the size of the image is highly diminished. That means a very point size image is formed. And third, the image formed is real and inverted. Very important points. So this was the first ray diagram when the object is at infinity. Let's move to the next part, next ray diagram, where we say that the object is beyond 2f1. Now again, this is f1, this is 2f1, this is f2, and this is 2f2. Now if we consider an object beyond so sorry let's assume there's an object which is here, and this is, first of all, first ray is parallel to the principal axis. Now we know the rule. When the ray is parallel to the principal axis, it passes through focus. Now we take the second ray which passes through the focus. Second ray passes through the focus, and it becomes parallel. So if you see, the image formed here is this. Now, if you can see, if we can write down the properties of the image formed, so this will be image formed between f2 and 2f2. Next, size of the image is diminished and last one, again you can see that image is real and inverted. So this was the second ray diagram. Now if we start our third ray diagram, where image, sorry, object is at 2f2. That means we call it as a center of curvature. Now, if you can see, again we will point out the focal points f1, and this is 2f1, where this is 2f1, this is f2, and this is 2f2. And obviously this is the optical center. Now, if the object is at 2f2, 2f1, so let's draw the object. This is the object at 2f1. Now let's see where the image is formed. The first ray, again, it is parallel to the principal axis, and after diffraction, it will pass through focus, which is f2. The second ray, which is passing through the optical center, and it will be it will pass through optical center undeviated. Now, if you can see here that the image is formed here at 2f2. Now, if we can write down the properties here, the first property is image formed at 2f2. Secondly, size of image is same as size of object. And the third point is, again, you can see that it is real and inverted. So this was the third ray diagram. Now the fourth ray diagram, which is object between 2f1 and f1. So this is the focal point f1, this is 2f1, this is f2, and this is 2f2. Now, let's say we have an object between 2f1 and f1. So we have rays, the first ray again parallel to the principal axis, and it will meet at the focus. We will extend the ray here. Now, the second ray will pass through optical center, and they will meet at this point. Now you can see this point. If you draw the image, this is the image formed. Let's write out the properties of the image formed. So image is formed beyond 2f2. The second point is size of image is enlarged, or you can also write magnified. And the third is the image formed is again real and inverted. This was the fourth ray diagram. The fifth ray diagram we have is when the object is at F1. So this is F1, this is 2F1, this is F2, this is 2F2, and obviously this is the optical center. So the object is at F1, again we will draw the ray diagram where the ray parallel to the principal axis it will pass through focus. We'll extend the ray. Similarly, the second ray which passes through the optical center will be undeviated. There will be a slight difference in the actual ray diagrams and what we draw over here. But you can see here that the rays are parallel, or we can also say that they will meet at infinity. Now, if you can write down the properties of the image formed by the object which is at F1. So first property is image formed at infinity. The second point is size of the image is highly enlarged. And the third point is, again, there'll be a real and inverted image formed. So this was the fifth ray diagram. Now, the last sixth ray diagram is very, very important, and this is what they generally ask in the question paper in IGCSE paper. So object between F1 and O. We know what is O. O is the optical center. This is F1. This is 2F1. And this is O. I'll show it. O with this black pen. This is F2 and this is 2F2. Now if you draw an object between F1 and O, so first is we draw a parallel ray which is parallel to the principal axis and which passes through F2, and we draw the second ray which passes through the optical center. Now you can easily see that both the lines are diverging lines and they will never meet. But when you extend these lines backward, extending these lines backward, they meet at a point. So this is where we get an image. See, the positions may be like slightly different because this is a freehand diagram. So this is where we get the image formed. So if we can write down the properties over here, first is image formed on the same side of the lens as the object. The size of the image is obviously, you can see, magnified. Or enlarged, you can say. And this is the only case in convex lens where the image is virtual and erect. So this is a very important case in the image formation by a convex lens. So this was all about the ray diagrams and image formation by a convex lens. Thank you so much.